good day. Now in the next 10 minutes, we are going to discuss about the properties of integers. So before we proceed to the properties of integers, let us first know some of the notations that we're going to use in the understanding of the properties of integers. So first on the list would be letter E facing to the left with a line on the side, which means there exists uniquely. Then is a inverted capital A, which means for any. Then a Greek letter, which looks like a letter E, which means element of. And last but not the least is a capital letter C, which we will use to note of the set of integers. So first, what are integers? So integers are set of numbers in the real number system, which is consisting of positive numbers and negative numbers, of course with zero in between. Now the first property that we're going to discuss is the commutative property. Commutative property now states that if A and B are elements of the set of integers, then A plus B is equivalent to B plus A, and A times B is equal to B times A. Example, 2 plus 1 is equal to 1 plus 2. 2 plus 1 is 3 and 1 plus 2 is also 3. Then 3 times 4 is equal to 4 times 3. 3 times 4 is 12, and therefore 4 times 3 is also 12. Next in line is the associative property. In associative property, if A, B, and C are elements of the set of integers, then quantity A times B times C is equal to A quantity B times C, and B plus C plus A is equal to A plus quantity B plus C. Example, quantity 4 times 7 times 8 is equivalent to 4 times 7 times 8. 4 times 7 times 8 is equal to 224, and 4 times 7 times 8 is also 224. Next example, quantity 2 plus 3 plus 4 is equal to 2 plus 3 plus 4. First, add the numbers inside the parenthesis. 3 plus 4 is equal to 7. 2 plus 3 is equal to 5. Add 4 and add 2, that would yield 9. So the next property would be inverse property. So inverse property states that if A is an element of integers, therefore there uniquely exists negative A, which is also a member of integers, such that if A plus negative A would be 0. Example, 8 plus negative 8 would be 0. 8 plus negative 8. In addition of integers, addition of unlike signs would yield to subtraction. So subtracting the same number by itself would be 0. Next is the identity property. Identity property simply means that if A is a member of the set of integers, then A plus 0 is equal to 0 plus A would be A. So example, 4 plus 0 is equal to 0 plus 4, or 4. So 0 is the identity element of addition. Next is the A times 1 is equal to 1 times A, so it would be A. Example, 5 times 1 is equal to 1 times 5 is equal to 5. So therefore, 1 is the identity element for multiplication. So next property would be distributive property. So distributive property says that if A, B, and C are elements of integers, then A times quantity B plus C is equal to quantity A times B plus quantity A times C. So A would be distributed to B and plus C, so it would be like this. So I'll write in subtraction, A times quantity B minus C is equal to quantity A minus B minus quantity A times C. So A would be distributed to quantity B minus C. So instead of addition, like on the first equation, it would be subtraction. So example, 6 times quantity 3 plus 2 is equal to quantity 6 times 3 plus quantity 6 times 2. 3 plus 2 is 5 times 6 would be 30. 6 times 3 is 18 plus 6 times 2, 12, which is also 30. Another example for subtraction, 3 times quantity 4 minus 1 is equal to quantity 3 times 4 minus quantity 3 times 1. So 4 minus 1 is 3 times 3 is 9. 3 times 4 is 12 minus 3 times 1 in the identity property, it will be 3. So 12 minus 3 would be 9. So the next property in line would be the closure property. So in discussing closure property, we will have first take into consideration some of this equation. So in addition, 8 plus 3 is equal to 3 plus 8 or equals to 11. In subtraction, 8 minus 3 is equal to 5 and 3 minus 8 would be negative 5. Set this aside. For multiplication, 8 times 3 is equal to 3 times 8, which is 24. And last, in division, so we will have 8 divided by 2 and 2 divided by 8. 8 divided by 2 is 4, but 2 divided by 8 would yield a fraction or a decimal. So therefore, looking closely at these examples, addition, subtraction, and multiplication all have closure property, but division doesn't have closure because not all the answers of division would yield for a integer. So not all the answer is a part of the set of integers. So we are discussing only the properties of integers. So we will only stick to the set of integers. So therefore, division doesn't have a closure property. Next is the zero property. So zero property, from its name, zero. So if A times B is equal to 0, then more likely A is equal to 0 or B is equal to 0. Or in some cases, maybe both A and B is 0. So after discussing several properties like distributive property, associative property, commutative property, and zero property, let us also take into consideration the other properties such as the transitive property, the symmetric property, and the reflexive property. So first would be the transitive property. So transitive property simply says that in any A, B, and C, which is a member of the set of integers, A would be equal to B and B would equal to C, then more likely A should be also equal to C. So in symmetric property, in any A and B which are elements of the set of integers, B is equal to A, and therefore A should also be equal to B. So last is the reflexive property. So in reflexive property, it simply says that in any A which is an element of the set of integers, A should also be equal to A because any number should be also be equal to itself.